This paper aims to improve surgical safety with a magnetic actuated laparoscopic camera by recovering the stress distribution on deformable tissue. Our previous work has been able to measure the camera-tissue interaction forces non-invasively. However, it's the magnitude and duration of the stress on the tissue that determines whether an irreversible tissue damage could be caused. In order to establish relations between the contact force and the stress distribution, we built a camera-tissue interaction model. We first described the viscoelastic tissue property using multiple Kevin Voigt models. Based on this, we modeled the camera tissue contact profile and the stress distribution. Finally, explicit relations between the contact force and the stress distribution have been reached. The modeling results have been simulated and compared with experimental results on porcine abdominal wall tissue. We first simulated the stress distribution based on tissue parameters approximated using linear least square parameter fitting as proposed in our prior work. The simulation was performed at a certain tissue indentation of 2 mm with a maximum stress of 452 pascals. Then, we simulated the camera tissue interaction forces at different tissue indentations by integrating the stress over the tissue. As expected, the maximum contact force of 274 millinewtons occurred at the largest tissue indentation of 4 mm. The tissue becomes stiffer as the indentation increases. More importantly, we verified the model by comparing the simulation results with data collection from experience on a piece of pork tissue. The experiment was done in an ex vivo setup assisted by a non-invasive camera tissue interaction force measurement approach. Meanwhile, a RealSense Intel 3D depth camera was utilized to measure the tissue indentation. During the experiment, the actuator was moved up at a step length of 1 mm until the camera fell off the tissue. At each step, the contact force and the tissue indentation were recorded. The simulated data using the model showed great agreement with the experimental data, which indicates effectiveness of the model. Once the contact force is measured, this model can be used to predict indentation as well as stress distribution. Thank you for watching.